everyone! Today we are going to look at how you can use ONNX Runtime in C++. So the first thing I'm going to do is to create a new project, and we're just going to do a console application for C++. Now that I have the starting console application for C++, let's go ahead and manage our NuGet packages and install the packages that we need. So we're going to need the ONNX Runtime package. We are going to be using Opencv, and so we want to install the Opencv libraries that we'll need. Okay, so now we have our ONNX Runtime library installed, and we have the Opencv libraries that we need. Now let's go ahead and add the includes for ONNX Runtime and CV that we just entered. Okay, let's go ahead and get rid of this. We're going to create our environment, which needs to be created in order to use ORT. We're going to create our run options. And then last, we want to create our session. Next, we're going to add in some variables here. We have the number of channels for RGB. We have the width and the height of the image that's expected, the number of classes, and then we are able to calculate the number of input elements. Now, if you've been watching any of the other videos on our channel, this looks very familiar to you, as this is the ResNet model that we've shown you how to use in JavaScript and C#. Next, I'm going to paste in my assets folder. And what's in here is a sample image. So this is our golden retriever image that we'll use. And then we have our classes. So it's just a text file with our classes, and then our model. And you can get this model from the ONNX Model Hub. Now I have added in those assets, and I've also added in some code here to do our inferencing, which I will walk through. But the first thing I want to do is fix the fact that we are missing the load labels and load image functions. So I'm going to go ahead and add a new class. Of course, I need to add my includes, and we're going to create the two functions that we need to load images and load labels. Let's take a look at our helpless class that we just created. We're going to include the libraries that we need, and then we are going to load the image. We're going to send in the string path to our helper function, and we're going to default the size to 224 by 224, but however, if you had an image of a different size, you could go ahead and send those in. We're going to read that file into our image object. We're going to check and make sure it's not empty. We are going to use the convert color from Opencv to take in the current image, convert it from BRG to RGB. So we have our in image and our out image as the same object, and we're letting it know how to convert that. Then we're going to resize the image to the size that we sent in, which is the 224 by 224. We're going to reshape it. And then we are going to use the convert to normalize the values between 0 and 1, and then also to convert it to that vector float, so an array of floats. Then we need to transpose our array from height with channel to channel with height. And the load labels is pretty self-explanatory. We're just loading in each line into an array of strings or a vector string and returning them back to our main class. So here you can see that we have loaded the labels and the image. Next, we're going to create our ORT session, and we're going to send in the environment, the model path, and those session options. Next, we're going to define the shape of our input shape, our output shape, our input array, and then also our results array, so our output array. And we're going to be using those to create our ORT tensors. So let's take a look. First, we need to create our memory info, which is telling it that we are using CPU and allocating that device. And then we're going to go ahead and use that memory info to create our input tensor and our output tensor. Then we're going to actually take that image vector and copy it to our input. So as you know, when you create an ONNX model, you define input and output names. We're going to go ahead and use the session to get the input name and the output name. And now that we have the input and output name, we are ready to run inference. So we're going to just do session.run, which should look very familiar if you've used ONNX Runtime in any other language. And once we get those results, we're just going to go ahead and sort descending and then print out the top 5. So let's go ahead and run this on our sample data. So we can see our 1, 2, 3, 4, 5 golden retriever, which is correct. And we can see that our model is working. Well, that was a quick example of how you can use ONNX Runtime and C++ with ResNet 50. Be sure to like and subscribe to stay up to date on the content that we are putting out, and be sure to leave comments and let us know what kind of content you want to see next.